Hello everyone, I welcome you all in this course Introduction to Sequence Stratigraphy, and as part of the series of discussions on different types of systems tract, in today's class we are onto the last part of that particular discussion, where we are going to discuss about a particular systems tract which is not commonly defined, but again it is in practice, and it is called as a regressive systems tract, commonly abbreviated as RST. So, as we have seen the other systems tracts which can form during the entire phase of base level change. So, RST, the regressive systems tract, is also part of that base level change that occurs within the base level change, and it comprises of all the regressive deposits which are forming during one phase of base level change. So, the RST, it includes all strata which accumulate during the shoreline regression. So, when we are trying to define the RST, regressive systems tract, in those cases we are not differentiating between the high stand systems tract, the falling stage systems tract and the low stand systems tract. So, all these three systems tract, they are merged together, and overall we are trying to define a progradational stacking pattern across the entire basin. So, when we are defining the RST, it is commonly bounded at the base by the maximum flooding surface, because we are starting from the end of the transgression where the regression is starting. So, it is the start of the HST, and already we know the boundary between TST and HST is the maximum flooding surface, which can be traced both in the marine part as well as in the non-marine part. So, for the regressive systems tract, the lower boundary is the maximum flooding surface, which can be marked, which can be demarcated in the marine part as well as in the non-marine part of the basin. Whereas at the top part, the RST is commonly bounded by the maximum regressive surface in a marine succession, and if we look into the continental side, there it may be bounded by a subaerial unconformity. So, if I refer back to this curve now, so if this is the base level curve, so we already know that this part is the HST part, followed by this entire zone is the FSST zone, and then this portion is the LST zone. So, this is LST, this is the FSST, and this is the HST. So, when we are talking about the regressive systems tract, we are looking into this entire package starting from here, the high stand systems tract, and ending up over here. This entire package is now part of the RST, which is together combinedly these three systems tract together is called as the regressive systems tract. So, the underlying unit is the TST, overlying unit is the TST. So, when we classify the systems tract like this, then we have two systems tract only, either it is a TST or it is a RST. So, we already know that when it is a TST, it is the fining upward succession, and at the top of that we have the maximum flooding surface. So, above this we will get the RST, which will be coarsening upward. As it is going through continuous regression, it should be a coarsening upward succession. So, the succession is ending up at the LST or at the LST-TST transition, and already we know that this particular surface is commonly marked by maximum regressive surface, particularly in those areas where continuous deposition is going on. So, where we get this one? So, if I draw this fluvial system to the marine basin, already we know that during the LST the deposition is mainly concentrated over here in this part along the self edge, where the self edge delta is forming, and there we can expect fluvial onlap and formation of this maximum regressive surface. So, in this area above this we are getting onlapping transgressive package. So, in this area the maximum regressive surface will act as the bounding surface. However, if I look into this part where fluvial onlap is not affecting, where fluvial onlap has not covering up the subaerial unconformity, river is still incising in that part, or maybe it is not incising anymore, but it is not aggrading as well. So, in those areas the bounding surface is the subaerial unconformity surface. So, when you have the subaerial unconformity, so in the non-marine part this will act as the bounding surface for the RST. So, the lower bounding surface for RST is fixed, it is the maximum flooding surface, whereas the top bounding surface it will vary from marine part to the non-marine part, and it is the maximum regressive surface to subaerial unconformity depending on in which part of the basin we are looking at. So, the amalgamation of all the regressive deposits into one undifferentiated systems tract is commonly feasible or is commonly practiced where the available database is not sufficient enough to distinguish the pattern of stratal terminations, that kind of stratal terminations which help us to differentiate between the different systems tract, where we do not get characteristic stacking patterns associated with those stratal terminations, which help us to demarcate individual systems tract like HST, like FSST, like TST. And in those kind of conditions, due to that insufficiency with respect to data availability, we cannot separate between the different genetic types of the regressive deposits. So, in such conditions, in such instances, the use of regressive systems tract over individual systems tract like the low stand systems tract, falling stage systems tract or the high stand systems tract is more preferred, because it will provide us the entire depositional story, it will provide us a continuous succession. Because if we try to identify or try to demarcate the individual systems tract forming during this regressive phase, we can face difficulty in the recognition of some of the surfaces, some of the bounding surfaces for those systems tract that separates the low stand unit, that separates the falling stage unit, that separates the high stand unit. Where we can expect this kind of difficulties? Very commonly we face difficulties with respect to identifying the correlative conformity surface. Very commonly we face this kind of difficulty with respect to identification of the BSFR surface. Very often we face this kind of difficulties in terms of identifying the RSME surface. And when we are not able to identify these surfaces, the packages bounded by these surfaces, that also becomes questionable. So, in this kind of scenario, we prefer to define a single systems tract covering up the entire regressive package as the regressive systems tract. When we are going through this kind of approach, commonly we are defining the upper boundary as the maximum regressive surface in one part and the subaerial unconformity in other part. So, the upper boundary of this regressive systems tract, that is a big question mark, because subaerial unconformity and the maximum regressive surface, as we have gone through our discussion on the low stand systems tract and the falling stage systems tract. So, we know that subaerial unconformity is forming during the forced regressive phase, it is forming during the falling stage systems tract in the continental part, and maximum regressive surface is forming at the end of the low stand systems tract, that is by the time already the base level has started rising up. So, there is a time gap, there is a time gap in between the formation of the subaerial unconformity in the non-marine part and the formation of the maximum regressive surface in the marine part. So, there is a time offset in between these two surfaces, but for regressive systems tract we are using these two completely temporally offset surfaces as a single bounding surface, as the upper bounding surface for the regressive systems tract. So, that is one of the major drawback. We face this kind of drawback in case of transgressive regressive sequence, in case of tier sequence that we have discussed earlier in our class. So, exactly same kind of problem, same kind of drawback we face when we try to define the regressive systems tract in terms of defining the upper bounding surface. Within the non-marine portion of the basin, the regressive package commonly incorporates the subaerial unconformity. In the non-marine package, subaerial unconformity is the upper bounding surface, and we are considering that. We are defining that one as the upper bounding surface, as we are considering that the fluvial onlap has not covered up the unconformity. But there may be cases where we can get some fluvial onlap has covered up the unconformity surface. But those fluvial onlaps, as we are saying, the onlap, they will be always a fining upward succession, as we have discussed earlier. So, within these low stand fluvial onlap portions, or maybe some portion of the low stand shore deposits, low stand coastal plains, low stand alluvial plain deposits, they can preserve some onlapping pattern formed under the low stand phase, formed above the subaerial unconformity as part of the low stand deposit. So, that portion forming in the non-marine to marginal marine part are commonly overlooked or commonly not considered as part of the RST, as in the non-marine part we are considering the subaerial unconformity as the upper bounding surface for the regressive systems tract. So, in such cases, the regressive succession includes the deposits which are genetically unrelated, which are genetically not juxtaposed, laterally continuous. Say for example, we are getting a high stand deposit at the bottom and a low stand deposit overlying the subaerial unconformity. Now, the low stand deposit is a fluvial deposit, whereas the high stand was a shore deposit. So, these two are actually indicating deposition during two different cycles of the base level change. So, subaerial unconformity becomes a true boundary between the regressive and the overlying transgressive deposits, because particularly in the non-marine part and in the marginal marine part, the deposits which are forming during the LST phase often show similar kind of onlapping pattern, similar kind of fining upward pattern in terms of stratal stacking pattern as we get in case of transgressive deposits. And it becomes very difficult often to distinguish between these two surfaces or distinguish between these two packages of sediments. When you look into the shallow marine part of the basin, the regressive package commonly displays overall coarsening upward pattern, and that coarsening upward pattern relates to the basinward shift of the shoreline, which is a very common phenomena associated with any regression, and that particular phenomena we can expect starting from HST, where a delta system progrades, followed by FSST, where definitely the entire system is prograding, and during the LST also the self-edge delta that progrades. So, overall during the RST, the shallow marine portion that shows a basinward shift of the shoreline. So, overall we get a progradational trend. However, it may not be a shallowing upward trend. As we have discussed in the earlier case, when you look into the non-marine part, where gradually the fluvial system is aggrading and the fluvial system is prograding. So, there gradually the proportion of channel fill is to overbank, that ratio goes on changing, and that can be associated with some more shallower deposits or maybe associated with more fining upward deposits. And many a time we can expect that relatively deeper deposits which are having a more coarser sediments available produced in the late phase of this regression. Say for example, we are getting HST delta is forming more towards the landward direction. The shoreline is more near to the land, whereas the LST delta, the self edge delta, it is forming more inside, more towards the basinward direction. So, in the vertical succession, HST overladen by the LST, so overall it is not shallowing up. The high stand surface deposits are always gradationally based and they tend to be relatively thick, commonly more than the depth of the Fairweather wave base, and they commonly reflect the overall tendency of aggradation along with progradation during the base level rise. Already we know that is the highest base level condition and lot of accommodation is created, and that accommodation is consumed by successive supply of sediments. So, we get overall aggradation plus progradation, which is characteristic of the high stand. The thickness of the falling stage surface sands, they commonly tend to be less than the Fairweather wave base as the base level is gradually decreasing, gradually falling, leading to less amount of accommodation available in the system, higher amount of erosions going on associated with this force regressive phase, and that leads to relatively thinner surface sands. Whereas, if we look into the low stand surface deposits, again the base level is rising up and they are again generally gradationally based, excepting for the earliest lobes which are accumulating on the distal RSME surfaces, those surfaces, erosional surfaces formed during the force regression. And these low stand surface deposits, they commonly tend to be relatively thicker if I compare that with respect to the FSST deposits, because these are forming when the base level again is rising up. So, the wave depth, the wave base, its position is gradually also rising. So, this will lead to more thicker deposits, relatively thicker deposits with respect to the FSST part, more similar to the high stand deposits, as they will accumulate and they will aggrade during the rising base level condition during the low stand phase. So, starting from the HST to FSST to LST, we are getting a changeover in terms of the pattern of accumulation of the shore face deposits, and their positions will also vary depending on the relative position of the shoreline during different phases of HST, FSST and LST. Now, if we look into the deep water part, in that area, in the deep water setting, the regressive systems tract, it commonly records a significant change with time in the overall character of the sediment supplied, which is reflected in terms of overall change in the character of the gravity flows, which are coming down to the deep basinal part, which are coming down to the basin floor in successive phases. As we have already discussed, during the early force regression, we commonly get mud flow. Followed by that, during the late phase of the force regression, we commonly expect high density turbidity currents, high density turbidity deposits are coming up over there. And during the low stand normal regression, these high density turbidity currents are replaced by low density turbidity currents. So, with time, as we are moving from early phase of force regression to late phase of force regression to the low stand normal regression, there is a change in the nature of the turbidity current, there is a change in the nature of the sediment gravity flows which are developing. And if I add the HST part, which is the lower unit of the RST, there we do not get any kind of gravity flow, and commonly we get basinal sedimentation, which is represented by pelagic or hemipelagic mud. So, within the RST in vertical succession, we can expect a gradual changeover within the vertical profile. We can call it as a composite vertical profile of the deep water succession that is forming during the RST. So, within this kind of composite vertical profile, what we expect, In the lower part, we expect a coarsening upward succession, which starts with a pelagic facies which have formed during the HST, that is succeeded by a mud flow deposit formed during the early phase of forced regression, which is further followed by high density turbidites which is rich in sand formed during the late phase of forced regression, and this is overlain by finding upward succession of the low density turbidites which are forming during the base level rise, starting with the low stand system tract and continuing into the next transgressive system tract. So, we can expect an overall change in the distribution pattern of sandies to mud within the deep basinal succession throughout the RST. The depositional products of such gravity flows gradually prograde into the basin during the shoreline regression, and they accumulate on the top of the underlying high stand pelagic sediments. So, if I want to understand this with a little bit more clarity, so in the lower part, say for example during the HST part, we are getting a mud deposition which is basically the pelagic mud formed during the HST. So, this is not associated with any kind of gravity flow. So, this is part of pelagic mud. Now, on this HST, what we expect is start of the forced regression, and during early phase of forced regression again we expect some deposition in terms of mud flow which are forming during the early phase of forced regression. So, this mud flow will continue till the end of this early phase of forced regression, and this will be replaced by a high density turbidite where we have dominantly sand. So, this is the high density turbidites which is sand rich, and this is forming during the late phase of falling stage system tract. So, in this part as we are moving up, the sand is to mud ratio, this is gradually or drastically increasing. So, from this surface onward, which marks the end of the forced regression and start of the normal regression, so there we get a changeover in terms of the gravity flow, and there it starts with low density turbidites. And as we know, during the LST part we get successive low density turbidites. So, this is the LST phase, and during this LST phase, since now the deposition is going on at the self edge, the self edge delta is forming and sand is supplied. So, these individual gravity flows which are represented by low density turbidites with sand, and associated with that significant amount of mud is also available. So, in this kind of low density turbidites, commonly the grain size will be gradually decreasing upward in successive turbidite deposits, but they will be progressing forward as the entire shore line is progressing forward. So, individual turbidite deposits, they will be progressing forward, and this will be overlain by another fining upward succession which will be forming during the next TST, which is again a low density turbidite, but here the sand proportion is further less with respect to these earlier phases, and here now the turbidite deposits will show a retrogradational pattern, a backstepping pattern. So, overall if I start from here, starting from this HST part up to this end of LST, throughout this area we are getting a progradational pattern, in terms of stratal stacking pattern, in terms of accumulation pattern, and where gradually the submarine fan system is progressing forward with gradual progradation of the shoreline. So, this progradational pattern is the characteristic of the RST. However, within this RST, we are not getting a continuous coarsening upward pattern. So, what we are getting over here, up to this point, we are getting a coarsening upward pattern, and above that, from this point onward, we are getting a fining upward pattern as the grain size is now gradually decreasing. So, the point of changeover from progradational to retrogradational pattern in terms of startle stacking nature, and the point of transition from coarsening upward to fining upward within this deep basinal or basin floor submarine fan system, they are not matching, they are not juxtaposed with each other. There is a temporal offset. So, in terms of grain size distribution, we get initially coarsening upward, which is leading up to the end of the late phase of forced regression, late phase of falling stage systems tract, and this surface will be called as the correlative conformity surface. This surface is definitely the maximum flooding surface, and this changeover from HST, that is the deposition of pelagic mud, to start off the falling stage, that particular surface is definitely the BSFR surface. So, within the overall package that is forming in the deep basinal part, we can find out all the depositional systems with respect to characteristic depositional pattern, with respect to characteristic facies architecture are recorded, but their accumulation pattern, their startle stacking pattern, that varies gradually in the vertical profile. So, this changeover, this turnover point, where we are getting a changeover from progradational to retrogradational, demarcating the end of RST and start of TST. So, this surface is definitely the maximum regressive surface over here. So, during the RST phase, when you are looking into the deep basinal part, a significant changeover, a significant transition can be observed in the vertical profile, where we can identify an overall progradational pattern, but that progradational pattern is not necessarily coarsening upward pattern. It can be varying from initial coarsening upward to fining upward pattern within the RST, but overall it is a progradational pattern, and that progradational pattern will be truncated by backstepping TST deposits. Again, these are low density turbidites, but those backstepping TST deposits. So, when we look into this kind of successions in the deep basinal part, we can very easily identify the maximum flooding surface, which demarcates the base of the regressive systems tract. We can find out very easily the maximum regressive surface, which is forming the top of the regressive systems tract, and that we can identify with respect to changing pattern progradational to backstepping. So, sometimes it may not be very clear, very distinct. So, we have to be very careful in terms of its identification with respect to the changing stacking pattern of successive turbidity deposits, and this particular aspect, the advantage and disadvantage of identifying the bounding surfaces in the deep basinal part within these successive gravity flow deposits commonly limits the demarcation of the regressive systems tract in the deep water settings, because in the shallow water part commonly we get lot of variations in terms of facies distribution, and their identification of these bounding surfaces MFS and MRS, they are easier, whereas when you look into the deep basinal part, since it is entirely the accumulation of successive gravity flows with minor changes in the sand is to mud ratio. So, we have to be very much careful in terms of identifying the bounding surfaces, in terms of identifying the overall extent of the regressive systems tract into the deep water settings. So, this brings us to the end of this particular lecture, as well as this brings us to the end of this particular series of lectures on the different types of systems tract. So, in this particular class, if I want to summarize, we have discussed about another systems tract which is commonly used in those cases when we do not have sufficient data to distinguish between individual systems tract forming during the regression. In such cases, we try to club them together into one single systems tract called as regressive systems tract. So, in this class, we have tried to understand about the different aspect of regressive systems tract. However, it is the combination of the HST, FSST and LST. So, definitely the basinal conditions will remain same, the processes, distribution of the individual depositional environments and the resultant products will remain same. So, we have not discussed about them again, as we have already discussed about individual systems tract HST, FSST, LST in our previous lectures. So, those concepts will be applicable over here again, but in this case just we are not differentiating them as individual units, we are clubbing them into one single profile in one single unit and we are giving the name regressive systems tract. So, these are some of the references for further study on this particular topic. Thank you everyone.